Yeah, it's me. I'm back again. Have you ever been in a situation whereby your electricians are working and you are scared to ask them questions because you don't want to look stupid, you don't want to sound stupid? And sometimes when you ask these questions, they look at you and like, what kind of stupid question is this? Yes, especially with the automation guys. The truth is, they expect you as the manager to have some basic knowledge, even better knowledge than they have. So they expect better questions, right? I've been in both positions. I've worked as automation engineer, I've worked as maintenance manager, then I've worked as reliability engineer. So I know these things. So as a manufacturing leader, operations manager, maintenance manager, engineering manager, even first line managers, you need basic automation knowledge for you to be able to ask the right questions. And that is what I'm going to teach you today. So I'm going to handling basic automation knowledge. Very, very important. After this class, I guarantee you that you'll be able to ask the right questions and be able to flow with your automation engineers. You need to know it. So, what do you need to understand? The first thing is sensor. Number one, sensor. So, basically, there are two categories of sensors. Don't overthink it. Sensors, you may have 100 sensors, but just two categories. You have the digital and you have the analog. This is just the two types. Under this digital, you have two again. It's either so it's either your is it normally closed or is it normally open. You get your analog. Basically, they are either using voltage or current. So this one they give you range, which is like 0 to 10 volts and 4 to 20 milliamps. So this one, the digital sensors, they just give you, their output is just one and 0. So whenever you see a proximity sensor, whatever, all it's giving you is 1 or 0. I'm seeing or I'm not seeing. Go or not go. Then whenever you see analog sensor, like your temperature sensors, your pressure transmitter, they are giving you range. They're giving you either 4 to 20 milliamps or 0 to 10 volt. But this is the most common, 4 to 20 milliamps. Now you're wondering, 4 to 20 milliamps, how am I going to read like tank level? Yes, it's called scaling. That is all. So now, what do you need to understand how sensors work? Because everything about automation is mostly sensors. I will teach you the basic knowledge of how they apply this in automation to give you the output. So basically, I said earlier, you have your digital input. For every PLC, you have your digital input, that is your DI, your digital output, which is your DO. You have your analog input, which is your AI, and you have your analog output, which is your AO. So there are a little bit more details around this, but you don't need it. All you need is what this is. So digital input is when the sensor is giving an input to the PLC. That is all. The sensor is giving an input to the PLC. Digital output is when the PLC is giving its own output to a feed device. as input. Don't get it twisted. Your sensor, I'll give it like this. Sensor gives you digital input, right? Your PSC gives digital output to a feed device. Now you want to ask, what is a feed device? It could be your electric motor. It could be your electric motor, your solenoid valve, your actuators. Let's use the word actuator. So the PSC use digital output to actuate. That's the correct word. The PSC use your digital output to actuate your feed device. So it will actuate your feed device. So close the circuit. Now, analog, your temperature sensor, they now give to your PSC. So this give to PSC. Right? Your analog, on the other hand, the input, analog input, which are still sensors, the analog input, they give to your PSC. Then PSC will kind of display or use it to do anything. While your PSC also gives analog output to your feed device. For example, VFD, that you need to ramp up the speed and decrease the speed. So your PSC will give it this variable. Now, this is the most important knowledge you need, right? How are you going to apply it? How is it being used in the program to make sense, to control something? I'm going to teach you very simple ladder logic. But I want you to grasp this very, very well. Just know that you have your sensors, right? Then the second thing that you have is your feed devices. Just take note of this. You have your sensors, then you have your feed devices. The sensor are going to read something. When they read, they will send it to the PSC. With the logic of the PSC will now actuate the feed device. So what's the third thing is the logic, which is your PSC logic. These are the three things that you need to understand. Example of sensors. Under the digital sensor, I've given you, under digital sensor, you have some proximity switch, right? Proximity switch. You have proximity switch. For example, your emergency button, they all give you digital input. Your buttons, all buttons. So, like I said, your these are digital, right? They're giving you 1 or 0. Just know that digital sensors are giving you 1 or 0, on or off, right? This is on or off. Then the second type of sensor is analog sensor, and they are giving you either 4 to 20 milliamps or 0 to 10 volts. For example, I said for analog, I said we have temperature sensor, that is like your RTD. You have pressure transmitters. You get. There are some very nice sensors like transmitters that can also give digital output. Like they have a set point, they will trigger an output. In that case, you are not interested in the digital output that they are giving you, which is either 1 or 0. With this basic knowledge of sensor, your feed device, and the logic. I've not explained this logic properly. I'm going to do it in a couple of minutes. But in any machine that you have, your process, you need to know the sensors that are there and the feed devices that are there. Example of feed device, I told you your motor, your pneumatic cylinders, um, anything that moves, you get. Your conveyor is being driven by motor. So take note of these things. Your sensors, your feed device. The interaction between the sensors and the feed device is through the logic, which is where you have the automation skill. So I'm going to teach you now about this logic. What you need to understand about this logic for you to make sense, especially for troubleshooting. So allow me to clean this part. So we're going to talk about logic. Now, logic that's the intelligence, how the sensor signals are combined to give output, right? The interaction between the sensors and the feed devices to give the desired output is found in the logic. Mostly, they are programmed inside your PLC, programmable logic controller. The most popular vendors are the likes of Simex, Ali Bradley. Those are very, very popular. I also have CDR, right? Now, what do you need to understand about logic? The easiest way to explain it is this concept of ladder logic. So I told you are going to receive just 4 things from your sensors. If you receive digital input, then it's like this. Digital input. It means that, let's say you have 24 volts here coming. This place is open. So you're not going to have anything here. So this type of circuit is called the normally open. I'm going to use red so that you understand what I'm saying. This normally open. You get until you press the button. Example of this is a button. This is a button, like a start button. A start button. You get, or your digital input sensors. Are we getting it now? The second one, another one of this is, it can also be normally closed. So this place, you are going to have 0. But here, if you have 24, you're going to have 24 here. So, meaning it's already closed. Like, if you connect the cables, voltage is current will flow, whatever. So, example is your, let's say your emergency stop, like your stop button, then emergency stop. You get it? Now, the next thing that you need to understand is your digital output. In ladder logic, is represented as this. This is like Q. So meaning When this input comes in, what is going to be the result that it will send? So this output can either be 1 or 0. You get? So in this place, I told you what is coming here is 0 now. Here is 1. So this output can either be 1 or 0. I want you to take note of this output. This output can also serve, this is output, right? This is output. So this output goes to your feed devices. It actuates, it's going to actuate, it's going to actuate your feed devices. Then you can use it as output, and you can also use it as input to your circuit. Stay with me, don't get confused. So the next thing is your analog. Now, before I go to analog, let me detail this. I don't want you to get lost. Now, when you press a button, a start button, you want to start your electric motor, what happens? You already have your system wired. Okay, I need to show you something again. For example, you have like your wiring diagram, let's say, then you have like a contactor, then output. Then this output goes to your electric motor. You get? Let me call this UVW. Yes, line 1, line 2, line 3. Now, this is a contactor. So this is a contactor. This is a contactor. Inside this contactor, there's a coil. Inside the contactor, okay, I'm going to use this red. I'm using red because it's your high voltage, right? I don't want you to miss it. So this could be 415, or if it is single, yeah, 415. Let's leave it like this. Inside of this, you are going to have your coil. This is a contactor. Inside, you are going to have a coil. So the coil is like this. So meaning there's a gap between the input and the output. So this motor will not run. So you are going to have auxiliary contact. Auxiliary contact here and here, which we call the A1, the A2, usually 24 volts, right? This your auxiliary contact, when it closes, okay, perfect. So in this auxiliary contact, now this is your start button. The cable from your start button, that is this, which is this, is 0 now. Once you close it, this 24 will go down here, then it will close this coil. Once you close the coil, this high voltage that is coming here will not connect directly to this. Then the motor is going to run. Once you press it, the coil will close, then the motor is going to run. What happens next? If you remove your hand, it's going to stop, right? If you remove your hand, it's going to stop. But you're not going to hold the button like that. That's why you have latching. So I'm using this to explain the concept of how you use digital input to get digital output and run your motor. Now, in the logic, in the PLC, this is what's going to happen. So basically, this is your this. So this is like you have your 24 cable, right? Now your 24 is going. This is the start button. Your start button. I'm going to call it SB. I'm going to call it SB. Your start button goes. Then you have your stop button. Okay, let me call it start. Then this is your stop. Your stop is usually normally close. Then eventually it goes to your feed device, which is going to be your electric motor. So this output now, it's what goes to A1. In your PLC, you are going to have signal module. So this is digital output. So in PLC, you have your digital input and you have your digital output. Then they have, depends on the size. So the cable from your start button will go to the input. You get it will come to the input, then this is the CPU. For the input, it goes to the CPU, the connector is behind. Then the CPU will see this logic and it gets the output. This is the output. The output will now come out and go back to your auxiliary contact. The output will come back to your auxiliary contact. So this is the Q, the output. The input is just a cable that comes. Let's say this is your button. It just comes in straight. Your button is coming straight to the signal mode digital input, to the CPU. It's not the CPU that will give you the digital output that will come to the auxiliary contact. You see why you separate electrical from electronics. Now, how is it going to keep running? There's what we call latching. I've told you this output can serve as input. So just imagine you have this output. You have this. This one now, this Q, let's assume that I have it, it becomes an input. Once you close this is going to come on, right? Once this comes on, this one will also come on, right? Because this one is on, this one is going to remain on.